Now we're going to get into solving quadratics. This you did in Algebra 2, so we're going to breeze through it fairly quickly. The part that you probably haven't seen is how to do it on your calculator maybe. And then the other part is how do you solve a quadratic inequality. So these are all equalities. They're all equal to something. You know, like this first one, 3x squared minus 11 equals 10. Well, what if it was like 3x squared minus 11 is greater than 0 or less than 0? Okay, these are called quadratic inequalities, and that's a whole different process. All right, lots of ways to solve quadratics. Okay, there's the most direct method, and it all depends on the equation that you're given, is called the square root method. Okay, then you have the factoring method. Then you have the completing the square method. And then the quickest way, and it works in all situations, is the quadratic formula. And actually we can download or we can program our calculators to do the quadratic formula, where then you only have to plug in A, B, and C, and it'll do the quadratic formula for you. So we'll do a little bit of programming. Okay. Okay. So today it's old school, do it by hand. All right. So the first thing you're going to do is see if you can use the square root method. Now, there's a couple of ways how do I know I can use this? Okay, you can use it when there's only one term that has x's. Okay, so solving using square roots only works if there's only one term with x's. So when I look at this first one, there's only one squared term. Okay, when I multiply this out, there's going to be one squared term. And then that's usually a good hint, use the square root method. Okay, so it's very straightforward. You just get numbers on one side and then the square root on the other. And then once you got the variable all by itself, you take the square root. Okay, so divide by 3, I get x squared equals 7. All right, now I take the square root. So the square root of x squared and the square root of 7. All right, now here's a part that you have to realize. When you write the square root symbol, I wrote a square root symbol. When I take the square root of that, there's a positive root and a negative root. Now the square root of 7 is going to be a decimal. So I would just leave it as positive root 7, negative root 7. So anytime you're solving something, if you do a square root of a number, you have to consider the positive root and the negative root. If the square root was already on the value, then it only refers to the positive root. So that's why I say, if in the process of solving something, you make a square root sign, you have to consider both the positive root and the negative root. Okay, so on this second one, if I distribute x minus 1 squared, I got to write it twice, and now I just FOIL it. So first, outer, inner, last. What is it? 2x. All right, and then that's going to be, hold on, folks, don't draw this just yet. plus 1. All right, now, don't draw it yet. Sorry. If I convert this into a quadratic, now I've created two terms that have x's on them. I can't use the square root method anymore. I'd have to multiply everything in here by 2. Don't write this down, guys. I'd have to distribute the 2 through. Then I'd have to add the 5. So this is going to take a lot more work. All right. If I treat the x minus 1 like it's a single term, okay, so instead of distributing or multiplying this out, what I'm going to do is I'm going to isolate x minus 1. So I want to get that all alone. So I'm going to subtract 5 first. So this is a quicker way than multiplying it all out. So that's going to be 24. Okay, now I'm going to divide both sides by 2, and I get 12. Okay, I still don't want to, I don't want to do this because that's going to create two terms with x's in them. So what I can do though is I can take the square root of this now. It's isolated. So once it's isolated, square root both sides. Okay, so now I'm going to square root, and I got x minus 1 equals plus or minus, now I got to do the square root of 12. Okay, now the square root of 12 can be simplified. There's lots of ways of simplifying radicals. Probably the easiest is just to do a factor tree. So I think what two numbers make 12? 3 and 4, 2 and 6. Okay, doesn't matter. I can use 3 or 4, I can use 2 or 6. Okay, 2 is a prime, so I can't break it down. 6 is not prime, so I can break it down to a 2 and a 3. These are both prime numbers. I can't go any further. Okay, if I am looking for square root, then I am looking for pairs. So here's a pair of 2's. So that, whatever the pair is, that goes on the outside. Anything left hanging goes on the inside. So this is a real convenient method for any kind of roots. Let's say I was looking for a cube root. Well, I could do the same thing, but now I'm looking for triplets. So 2 and 6, 2, 3. Now, since this is the cube root, I'd look over here. Anything that's a triplet, that would go on the outside. Anything left over goes on the inside. So this is going to be minus 1 plus or minus 2 root 3. Then I'm going to move the 1 over. See, I ran out of space. So this would be, I'm going to add 1 to the left, add 1 to the right, and I'd have 1 plus or minus 2 root 3. Okay, that is called the exact answer. Doesn't have any, I didn't use the square root key on my calculator. No decimals. Exact answer. So this was an example of where multiplying out x minus 1 times x minus 1 created more work. as opposed if I could just isolate it. Okay. All right, so here are just some other simple factoring ones. So that's the square root method. That's this guy right there. Okay, then just some real quick review of factoring. Factoring is always look for a GCF first. Okay, so I got a GCF of 5x. So I can pull that out. And pulling it out is the same as dividing. So in my head, okay, I'm dividing that and I'm dividing that. That's what factoring is. Okay, so when I do this one, I'm just left with x. When I divide that by 5, I'm left with 4. If you distributed this, it would turn back into what it was. All right, then you use the zero product property, which means if this is equal to 0, either 5x is going to equal 0, or x minus 4 is going to equal 0. Well, for 5x to be 0, x would have to be 0. And for x minus 4 to be 0, x would have to be 4. And those are the two solutions. Now remember, those solutions, guys, are the same as the x-intercepts. So if we were to draw this graph, it would go through 0 and it would go through 4. All right, the difference of two squares. All right, x squared is a perfect square. X squared is a perfect square. X to the 4th, x to the 6th, x to the 8th, x to the 10th. These are all perfect squares. If I do the square root of them, x squared, x3, x4, x5. Okay, 81 is a perfect square. So your perfect square numbers, okay, 2 times 2, 3 times 3, 4 times 4, 5 times 5, etc. Okay, these are called perfect squares. These numbers are called perfect squares. So this is called the difference of squares because it's a subtraction. All right, if you remember, the difference of two squares is going to factor into a plus b, a minus b. So a is the square root of the first term, and b is the square root of the second. So this is going to go into x minus 9, x plus 9. And then what makes each one of these equal to 0? 9 and 8. You did this. You've done this. Hopefully you remembered some of it. Okay, so that's a factoring pattern called the difference of two squares. Now the other two we've done. So this is called a simple trinomial because that is a 1. This is called a complex trinomial because that is some number other than 1. And that's the one that we used the box on the other day. Simple trinomials, pretty straightforward. What multiplies together to be negative 28, and at the same time adds together to be minus 3. So multiplies together to be negative 28, adds together to be negative 3, and what would that be? Negative 7 and 4? Yep. So negative 7 times 4 is negative 28. Negative 7 plus 4 is negative 3. So I can automatically factor this into x minus 7 x plus 4. So what makes the first one 0? 7. Second one 0. All right, so you always start with GCFing. GCF, GCF. All right, now to do the complex trinomial, we're looking for two numbers that multiply together. Am I going too fast? Is that a yes or no? We're okay? Okay, so this is going to be 3 times 12 now, so that's 36. And it's going to add together to be negative 13. So 36, 2 and 18, 3 and 12, 9 and 4, 9. Yep. 4, 9. They both have to be. All right, then when we did this in class the other day, we kind of color-coded things. These two terms go here. And then these two terms with x's on them go in those two boxes. Squared. Negative 4x. And then your factors are going to be along the rows here, and then along the columns. So then GCF the rows, then you're going to GCF columns, and what you end up with is your factors. All right, anytime a row or column starts with a negative, that's what you're going to pull out. You're going to factor out a negative. GCF between these two is negative 4. GCF between these two would be positive 3x. So that's my first root. And I do my columns, and that's my second root. Right, so up top, let's see if I go this way. All they have in common is an x. That's a leading negative, so I pull out a negative. Okay, now I want to figure out what makes each one of these 0. And there's my solution. So that's just standard factoring techniques. Now the next two, you're going to solve by factoring. But all I did was just make the equations so they're kind of mixed up a little bit. Then, so what you got to do is organize the equations first, and then go ahead and factor it. So this one's got a typo on it. That should be n plus 2, not a minus 2. Or an equals 2. That doesn't make any sense. So change that to a plus. I'm frozen. Yes. This one right here? This part. Oh, so I got 3x minus 4 equals 0. So I add 4 to both sides. And I get 3x equals 4. And then divide by 3. And x equals 4/3. Okay. All right, so this guy's a plus. So when they're not already, if you notice, all of these are set up so that they're equal to 0. So to solve this, what we're going to do is do the exact same thing. So sometimes you gotta clean them up a little bit. Okay, so this is going to take just a little bit of work to get it into shape, and then I'm going to factor it. I'm going to get everything on one side and 0 on the other. All right, so you just distribute. And then move everything to one side. And then you ask yourself, okay, I can factor that. This is a simple trinomial because it doesn't have anything. It just has a 1 in front of the n. Yep, so this would be -5, +2. So then my solutions, what makes each one of these factors equal to 0?
Mr. Krolak.
5.
Mr. Krolak.
All right, so really nothing special there.
Okay.
All right. now what you have in the next one is a fraction. So the easiest way to deal with problems with fractions in them is get rid of the fraction. So we're going to multiply everything by whatever that denominator is. So I'm going to multiply all terms by x. Now, if I do that, then I'm not going to have this fraction anymore. So each one of these gets multiplied by x, and this guy gets multiplied by x. And now, no fractions. Okay, move the sticks over. Minus 5x minus 6. Pardon me? Yep. So 6x squared. So it's got to multiply to be negative 36. And at the same time, add together to be negative 5. Yep. So let's see, negative 9, positive 4. And so those cats, 9x and now GCF your rows and your columns. All right, you got a leading negative, so I'm going to pull that out. Be 3. GCF of these two would be 2x. Okay, now the columns, 3x. Here, 2. And what makes each one of these equal to 0. Let's see. This one should be, thank you. So I should have subtracted 2, not added 2. All right, so there's our quick review of factoring. Are there folks still writing, or can I give about another minute? Okay, the next part you're going to solve by using your calculator. All righty. This should have, get rid of, okay, here's what we're going to do. We're going to graph this on our calculator. And then we're going to graph this on our calculator. And we're going to see where these two things cross using the intersect function. So that's going to be one function that I'm going to graph. And then the other function is the x equals 10 or 10. So you're going to end up with a parabola and then a line at y equals 10 going through it. And then you're going to find the intersection of those two equations. Right? So let's open up your calculators. Oh, there it is. All right. So y equals, I'm going to type in two equations, x squared minus 8x plus 16 and 10. X squared 8x plus 16. And then whatever it's equal to, that's your second equation. And then it's going to graph those. And then you're going to use the calculate menu to get the intersection. So I'm going to go 1. Okay, so I can barely see the top. So I'm going to change my window a little bit. I'm going to go higher on my Y max and shorten up the Y minimum so I can see more of the graph. Okay, so maybe make this -5. And, whoops. That's what happens when you use a subtraction and not the negative sign. All right, and now Y max, I'll make like maybe 50. There we go. So this is, we want to see what are these 2 points. Okay, so to do that, you go second, calculate, and you choose number 5 now, the intersect function. 5. Now, what it's going to do, you might have more than 2 curves on here, or more than 2 equations. It says, what curves do you want to find the intersection of? So the first curve it's blinking on is the parabola. So I'm going to hit enter. The second curve that I want to use is the horizontal line, y equals 10. So I hit enter. Okay, now the guess, I'm just going to move this over where I think it is. And hit enter. And there's my first intersection. Okay. So the x values are the. Okay. Yes. We're just about. Miller, Amaya, and Chris. All right. So if I did this to 3 sig figs, 0.833, that would become an 8. And then you repeat it for the other root. Okay, so once you have it here, it might do too much. So that's going to be our first root. And then repeat the process, and you're going to get your second root. So this, when we drew this, that, and then we had a line at y equals 10 going through it. That first root was approximately 0.8, was it 78? Hello? Yeah, okay. And now just repeat that process. Oh, 838, 838, not 878. 838. And now just do it again and get the other root. Okay, so that's one solution. And the other guy, second, calc, intersect. Okay, first curve, second curve, and now my guess is going to be over on this one, right there. Okay, and then this one to the nearest would be 716. And that's my other root then. Yeah, is that what I wrote? Oh, yeah, yep, it is. Thanks. So it's the x coordinate that is your solutions, not your y coordinate. All right, so what you just did was you found the approximate these are the approximate solutions. Now, if I said find the exact solutions, all right, so if I was going to do the exact solutions, and then if I was going to do it by using factoring, okay, now, if you just look up here, don't write this down. Okay, I'm going to move the 10 over. Now, if you try to factor this, can you think of two numbers that multiply together to be 6 and add together to be -8? Well, the numbers that make 6 are those two.
Attention students, Ms. Carver will be in the courtyard area during celebration for the raffle for the homecoming ticket. Again, Ms. Carver in the courtyard area to register for the raffle for the homecoming ticket.
Okay, so here you can't factor it. It can't be factored. Okay, so what happens with factoring is sometimes you just have to factor different things first. So if I move the 10 over, I'm stuck. I can't factor it. However, if I factor this first, I can. And you don't know, guys, until you try. All right, so I move that 10 over like I normally would. I can't factor it. Okay, can I factor it before I move the 10 over? Well, what two numbers multiply together to be 16 and add together to be -8? -4, -4. So that can factor into these two, which is that. Okay, now I can use the square root method. Solving that is going to be just like solving this one up here. Okay. So all I'm going to do now is square root it. X minus 4 equals plus or minus the square root. Move the 4 over, and there's the roots. X plus root 10 is one answer, and x minus root 10 is the other answer. So these are the exact answers. These are the approximate answers. Now these other examples, guys, we're gonna run short on time. To solve on your calculator, you do equations and then you see where they cross. So on the second one, I would just tighten the both. On the very bottom one, I'm going to put one side of the equation in for y1, and I'm going to put the other side of the equation for y2. And then we would use the intersect key to see where these things cross. So when you're doing the assignment, there's only one of them that you have on. When you're doing this part of that assignment, you're doing that one and that one on your calculator. 5 and 9 are both on your calculator. Okay. And then here you got C E, D, F. You're doing what's exactly on this page here. They're all listed for you. Yeah, and then that'll be due Monday. Yeah, the other ones, it tells you, this is just factoring. Yeah, they're listed on the paper. Right here. Right there, right there, right there. I don't know. You got to show your work on this. I'll show you what I mean. Because you don't do it on this. No, I'll show you here. Just give me a second.